Welcome, everybody. Thank you very much for coming to the first of what will hopefully be a few seminar series we'll be running as part of this new NSERC FlareNet strategic network we've launched here at Carleton in partnership with UBC, University of Alberta, Waterloo, Western University, a number of partners I'll talk about. You can see many logos on the screen. And today's seminar, we're very pleased to feature a presentation by our international collaborator, Dr. Olga Popovicheva of Moscow State University. We'll be talking about measurements, really interesting measurements in the Arctic. Not a lot of people have had the experiences she has had, that's for sure. So if we're looking a little tired today, it's because we've been running pretty much round the clock all week long in the lab. There's actually most of the team is back in the lab currently trying to finish up measurements. Visitors from UBC and U of A and a number of postdocs and students making measurements. Olga and I were, well, actually I haven't been in the lab that much, but Olga was allowed out of the lab to come make this presentation today. So we're very pleased to be here. I think we only have one-way communication, but I know we have Francisco Sucre from World Bank. He's one of the partners on FlareNet online and hopefully a few others. So a shout out there. I'd like to start in purpose of today's seminar. We wanted to talk about global gas flaring, implications for Arctic environments, climate change, and air quality. And so just for the very basics, gas flaring, the ubiquitous gas flare, is burning unwanted flammable gases. And this is a practice, as many of you know here, is found everywhere in the world. And the central questions are, of course, what is emitted? What are the magnitudes? How can we quantify a model? What's the mitigation potential? And really, how can we develop regulations that move the needle on flaring? The World Bank, one of our partners in this, has been trying to push down global flaring for a number of years now, frankly with a bit of marginal success. They've refocused this year and launched the Zero Routine Flaring Initiative. Canada has signed on to that, as have a number of other countries. There are a number of critical policy challenges in making that happen. And there's really important climate impacts in the background that Olga would talk more about. If you think about flaring in the world, approximately 146 billion cubic meters of gas are flared. It's really hard to get your head around that number. Satellite images help. This is North America. What you're seeing there is the Bakken Shale. That's North Dakota, southern Saskatchewan. Arguably, that's showing up, similar brightness level as Chicago. And of course, there's no city there. That's not Bismarck. That is flaring. If you look at what's going on in Canada, we had made some reductions if you plot the baseline back to 1999, but really since 2009, 5 years of data here, flaring has gone up 92%. And that is largely associated with hydraulic fracturing, something Melina Jefferson is going to speak about today as well. Saskatchewan, I bring this up because those are the two most largest provinces in terms of flaring and venting. Data is a bit more sparse, but the 2-year period we have data for an increase of 12%. That's the same kind of growth rate as we see in Alberta. So really quite frightening what's going on. But this is really a global issue more than anything. There are greenhouse gas implications, but especially critical implications on air quality. The Niger Delta, you can see the picture on the bottom, is a number of really important local development, air quality, social policy issues. We were at a meeting with World Bank just 2 weeks ago, talking to a number of representatives from Nigeria on these issues, trying to figure out what we could do to help them on the measurement side. The global challenges are really quite frightening. And the role of black carbon, which we'll talk about today, is really focused international attention. What this means, more urgent than ever, need for quantitative models, some kind of evidence-based regulation to try to move the needle. Let's reduce flaring. So I brought up black carbon. I thought a seminar like this, maybe we should pause here. What are we talking about? It's the carbonaceous component of soot. So this picture over here is about a micron, 1 micrometer wide. So this particle is, basically too small to see, and just the right size to go down in the deepest recesses of your lungs and stay there. On top of that, we call it black carbon because it's incredibly effective at absorbing sunlight. And so this has the twin evil effects of really strong warming potential. It'll deposit on snow and accelerate melting, and it's got really strong health effects. There are a few components of all the scary components you can think of out there, benzenes and whatever else. This is one where you can actually say is causally linked to human mortality. That's a pretty dire outcome. However, herein lies an opportunity. We've all heard of CO2 as a very important greenhouse gas. Methane, Environment Canada, pleased to have two representatives here, announced very important regulations for Canada yesterday for the first time in methane regulations. CO2 is a lifetime in the atmosphere of about 1,000 years. We absolutely need to mitigate CO2, but as much as anything, when we make a reduction today, we're doing it for our grandchildren. And if we don't, the trajectory, I'm not saying we don't need to do this, this is dire, we must. Methane is a really interesting opportunity with a lifetime of 9 years. If we make a reduction today, I get to see it in my lifetime. I get to see it, the effects of that in the climate in the next 25 years. And I think that's largely why Environment Canada and other countries in the world have moved so aggressively on methane. Black carbon is an even more interesting potential. The lifetime in the atmosphere is really only about 1 to 3 weeks. So if we actually manage to make a permanent reduction today, we see benefit by the end of the month. There are really no other opportunities we can think of in climate. And so the international community has understood this. Black carbon reductions are immediate climate benefits. It's a key motivation behind the United Nations Climate and Clean Air Coalition, which many of you might have heard of. So still on black carbon, I mentioned the effects on snow and surface albedo. We're going to talk about the Arctic a bit today. What does all that mean? It means it increases solar absorption. So here's a picture from the UN Arctic Monitoring Assessment Program. You can see the black carbon on snow in the Arctic. This should be pristine white. And now you've got the snow in these kind of fingered-like structures where the particles are accelerating melting, and you can see with your own eyes what's going on. A very important study in 2013 by Andreas Stoll, a colleague and co-author of Olga's, suggested that 42% of surface concentrations could be from gas flaring. So even though gas flaring might not be as significant compared to, say, transportation sources in the world, this is a very important source in the Arctic. And so again, the Climate and Clean Air Coalition is focused on this. And one interesting tidbit, there was an expert panel meeting in Ottawa just in March. I was lucky enough to be part of that. They're very close to coming up with an internationally accepted metric for black carbon. We talk about global warming potentials, some of you might know, for methane. We don't have one for black carbon that we all agree on, and that has been holding back regulations. That's coming soon. Still throwing out problems here. Let me switch a little bit. The issue of flaring and unconventional resource extraction. I showed you those trends in Canada and North America and the satellite pictures of the Bakken. Fracking, hydraulic fracturing, these kinds of recovery exercises have led to sharp increases in flaring. They have special concerns for climate, air quality, and health, and they have forced a number of reevaluations and practices. So that's another part of what we're going to talk about briefly today. So again, really an urgent need for measurement technologies, data, models. So what are we doing here? With this, under that backdrop, we've launched the NSERC FlareNet Strategic Network. And the overarching objective of this is science-based regulation, accurate pollutant inventories, understanding climate forcing and health implications, and assessment and mitigation strategies, all to minimize environmental impacts. And so we're fortunate enough to have Ministers McKenna and Duncan come to Carleton and launch this just a few months ago now, October 19th. So we're not even through our first full year. And with that, we're very pleased to talk about some of the early results today. So this is a $6.9 million five-year duration project, and it's a combination of large-scale lab experiments, which is really kind of fun, some of the things we're running today, and field work. I think we'll focus a little more on the field work today. And I mentioned Carleton University, U of A, UBC, Western, Waterloo, National Research Council. And the strength of this network is really in the partners. NSERC, of course, Natural Sciences Engineering Research Council. On the industry side, the Petroleum Technology Alliance of Canada and CAP. Internationally, the World Bank, Carbon Limits, United Nations Climate Clean Air Coalition, all the university partners, Natural Resources Canada, Environment Canada, National Research Council, and so a number of different perspectives that make this really quite an ambitious undertaking. A number of people involved, a bunch of smiling faces. These are the PIs from all around Canada, and Olga Pavlicheva joining us from Moscow State University. This network is overseen by a board of directors. Something of this scale, we're trying to make sure that this stays relevant as the in a very rapidly changing environment and industry. So Amin Asadullah from International Institute for Sustainable Development is our chair. On the industry side, Mark Anderson, some might know from Husky, Alberta Energy Regulator, Natural Resources Canada, Francisco Sucre, who's probably listening in, World Bank, Environment Canada, Dominique Blanc. So a number of people who might be familiar to those in the audience. What are you going to read here? Nothing. In the backdrop of the science behind this network, there are a number of wide open research questions. What's a real gusting wind due to flare emissions? I was just talking as we're getting ready to start. You know, how could somebody put an emission factor for flaring so they could count the impacts that these methane regulations are going to have when flaring goes up? How can we do that quantitatively? How can we make an economic judgment on that? There are so many questions that we do not have answers to that completely impede regulation, impede mitigation, and in large part is why, despite quite significant efforts by World Bank and a number of partners, we really haven't made a lot of progress. It's kind of depressing if you let yourself think about it. I like to think about the opportunity instead. So how do we estimate emissions? Without going into it, mostly we guess. We'll talk about that a little later on and when we talk about impacts in the Arctic and what they might really be. Huge problem for developing effective regulations. We don't really have technologies to go and measure a flare in the field and say, if some manufacturer says, my flare is 99% efficient, nobody can say otherwise. This is a fundamental problem with regulation. You can regulate whatever you want, but if you can't verify it, nothing happens. And we've seen a number of times, at least in our group, when we look at the economic side of this, how much this impedes the business case for mitigation. We've worked a lot with Amazonas and Ecuador. I'll talk about that. There's a clear economic case in my mind, local health case, but they don't have the data, so they never make the business case. They can't sell it higher up the company. There's just a logistical order on how things must happen to get things really done at the engineering level in the field. So within FlareNet, there are 5 closely integrated themes aimed at tackling those problems. First is on flare emissions during flowback at hydrofractured wells. So what happens during fracking when you flow back a well? Melina Jefferson is going to talk in much more detail about that momentarily, so I won't steal her thunder. Second looks at effects of air and steam assist on emissions control. We haven't heard as much about this issue in Canada, but this is, you can see some of the clippings down below. This is a very significant issue in the States. This video is still running. Thankfully, a bird came up so you could tell it's a real video. This is a flare we saw in Mexico during work with the World Bank. It's got a steam control problem. So they're adding steam to this flare to suppress the black carbon. So you can see the black carbon kicking in now. But they have a control problem. So they are, in trying to get rid of that, they're killing the flame entirely. So the efficiency, if you want to think of that, is going to 0% in those intermittent periods. You're releasing 100% of the unburned products, the VOCs, the benzenes, whatever's in there, oscillating between these large black carbon emissions. Very difficult control problem, almost no data. I actually sympathize for operators. I get asked questions about this. There's just no guidelines, no procedures for the companies who want to do this. Turbulent crosswinds. Any model data we have is done on winds that don't gust. So you can kind of see from these pictures, it's windy outside. That's a big hole in our understanding. What about the particulates that are emitted? This is important for climate forcing. This is important for health. When we talk about, I think Melina is going to show this picture momentarily. We talk about specific things that might be going on during hydrofracturing and flowback events, where you can get really bizarre things potentially emitted. We know nothing about this. And all this hinges on the ability to measure something in the field. It's one thing to have a lab model. Lots of us have done these sorts of things. We've had very little traction with lab models until we started making measurements in the field, and suddenly things get picked up. And so the idea of FlareNet is the linkage of actual work in the field when we can do it, uncontrolled and whatever we get, with things we can control in the lab. So with that, we're trying to aim in 5 years for these science-based regulations. Happy to talk about how. We're actually working with standards committees now in parallel, trying to work towards these things as this happens. Pollutant inventories, we're doing work on that currently. Climate forcing health implications, all trying to minimize environmental impacts. And so with that, thank you again for coming.